Hello and welcome to my program. My program was designed to allow easy user input, to allow them to get good feedback on speed ratings using cross-country times. The times put in are for 5K races. And so starting my program, I'll run it here. And so I use multiple packages throughout my program. And so the very first time the program is run, when it is opened, it'll have to go through this process of installing them. It goes by fairly quickly. And so every time after this, while my program is open, they won't have to download again. So the most important part of my program was taking a time inputted by the user and giving it back a speed rating. And the speed rating can be compared to any race that's used here. And so I'll hit 1. And so first it'll ask where the race is being held. And so I designed my program so far to only include the state level race, an invitational race called the GRIAC Invitational, and then a regional race put on by Nike. And so I'll start by entering state. And then it's going to ask me for the time, and it includes the format that it wants. So I'll type in 15:34.4. So right away it gave me back a speed rating of 178. And then after it gives me my speed rating, it gives the top 10 speed ratings ever in the history of this venue, which is in this case state. And so this meets multiple of my success criteria right away. So it immediately allows a variety of races around Minnesota to be used. State, GRIAC, and Nike are each very prominent and important races, and so results from each of those races can be compared. The speed rating gives the ability for the user to judge a performance. A time may be faster than another time from two different courses, but the speed rating levels it out and takes out any advantage or disadvantage a course may have. And so then it also allows a user to compare their speed rating to the top speed ratings from every year. And so this speed rating actually would fall in one of the top 10 speed ratings of all time for this venue. And so then it leads to another success criteria that involves being able to store personal data. So it's asking me if I want to save this result, and I'm going to say yes. If I were to say no, the program would simply say thank you and it would quit. But I'm going to say yes. And so for the runner's name, we're going to call our runner Tester Johnny, or Tester John. And then I'm going to write the year that this was run, 2020. And now it's saying all done, and the program ends. So now if I run the program again, you'll see that there's a second option, option 2, to open saved results. And so this will open the file that I just saved that last result to. So I'll type in 2, and now it's going to print, and right here we can see our last one we just inputted, Tester John. And so this is a personal file for the user that saves any inputted times that they wanted to, and so they could go back and put in Tester John for next year at the same event, or later in the year, and be able to compare their speed ratings to see if they're making progression or not. And then for the next thing that the program can do is through my giant text files that I have, or result files from the GRIAC, Nike, and state races, I'm able to iterate through them with option 4 and find any runner I want. So I'm going to look for Acer Iverson. He's someone who will have a lot of results that we can look for. So you type in their first name and last name, and this is done because the format of the results is not consistent, and so sometimes it's listed as Acer Iverson or Iverson, Acer. So I enter that, and it instantly iterates through all the list and pulls out every line that has Acer Iverson in it. So it goes through all the state results, all the GRIAC results, and all the Nike results. So this is a really easy way for users to be able to go and find past results of other people to get a general idea of what their times were. And so the final part of my program that's still kind of in an experimental stage, but could definitely be utilized further to really make this program a strong program, is the ability to enter new race data. So that would be option 3. So when they enter it asks for a race ID number for MileSplit, which is the website that is used to get all the results. And if we go to results, we can see up in the URL up top, there's this number here, a 6-digit number. So we're going to copy that and paste it in. So this is the race ID. And so what I'm about to do is I'm going to scrape the web for using a special API that MileSplit has designed that will allow me to open the results from this race like this, and it's going to organize them for me. And so if I go back to here, I have the race ID and I hit enter. If you watch over here, a new file just appeared. It's called race text. And so if we go ahead and open this race text up, we can now see that we have a formatted results with the first name, last name, and a time. And so this was not in my program at all before, and I went out and scraped the web and was able to ascertain this. And so due to restraints with time and just programming knowledge, I wasn't able to further utilize this. However, it will allow for my program in the future, on future improvements, to be able to look through race results in a very consistent form. Every single line has the same format, and I would not have to worry about different formatting and what that could do to my program, and I could easily pull the names and the time and use that for my own data. And so with my program, I was able to meet my success criteria, and then I was able to take it a step further in including some additional functions that it can do.